they are sending online.
What do you need for mic?
Mic is there.
Huh?
Mic is there.
But he need
No,
mic.
online. Okay.
He don't need mic. I think less audience. You need mic. Not required.
I don't think so.
Please come forward. Yeah? Please come.
Oh, it's okay. They can hear me from here.
You come. No need to say.
Good morning everyone. Welcome to the second day of ICISML conference. So we are glad to have you all here, and we hope the first day has gone very well with interesting talks and paper presentations. Now we have an interesting talk on blockchain applications by Professor Milos. I'll just brief him about him because we had a detailed, he has given an address during the inaugural also. So he is a full-time professor at Department of Computer Science and Electrical Engineering at Sigidunum University, Serbia. He has received his PhD at Computer Science degree at the School of Information Technology and Engineering, University of Ottawa, Canada. He has published more than 50 articles in the fields of computer vision, image processing, wireless networks, and machine learning with 1,900 citations and H-index of 20. He is an editor of 3 journals, Multiple Valued Logic and Soft Computing, Ad Hoc and Sensor Wireless Networks, and IEEE Open Journal for the Computer Society. We are looking forward to your talk, sir. So I request Professor Milos to take over the session.
Thank you. Good morning. Please stop me anytime if you have any questions, and I'll try to go through this as quickly as possible because we're running a little bit late already. So here we go. Blockchain applications and research directions. This is not a new topic. I think it's something that's been around for a while, but just because not a lot of people are fully aware of what's going on, I wanted to present this to you because it's something that I feel is interesting and may be relevant to you in the future as well. So I hope you find this interesting. Oops. Can we change? Ah, it's working. Okay, no problem. So here's what we're going to do for today as quickly as possible. First of all, first point, what is blockchain? Second point, commercial applications for cryptocurrency, which is a synonym basically for blockchain, or is the first application of blockchain. And research problems involving blockchain, that's all we're going to do. So let's do one by one. So the first thing is, what is a blockchain? So this is a definition, but this definition we need to get into a little bit, each term specifically. So a blockchain is an immutable distributed ledger of transactions. This has a lot of words. So we have to kind of dig into each one to see what this means. So first of all, what is going on? Sometimes it works, sometimes, here it is. So the first word that I wanted to discuss is distributed. Now, I feel that you probably know this, but we're going to discuss it in a few sentences anyway. So we have a few models of communication here. One is a centralized model, one is decentralized, and one is distributed, basically. And the centralized model you can think of as anything that requires one central point of contact in order to function. So you can think of this as, I don't know, a bank. And in order to do transactions with participants in this network, people have to communicate through the bank. So basically, if you want to send someone money, you have to go to the bank, send someone money, they receive it. And you need this central party in order to do any type of transaction, because without it, transactions are impossible. If the central fails, or if the bank fails, the parties cannot communicate with each other. So that's a centralized model. It applies to generation of electricity. It applies to many different things in life. So decentralized is a little bit more robust, but a little bit more difficult to maintain and requires more responsibility for each participant. So this decentralized model means that if anyone fails within these nodes, the rest of the network can still communicate with each other. And the final model, this distributed, is any one node fails, the rest of the network doesn't even notice and just continues to function without any problems. So the magic here of what cryptocurrency does, or what blockchain does, is it enables communication between parties without a centralized authority to authorize anything. So that's the benefit of the technology. But each participant in the network has a lot of responsibility. That's the trade-off here. So that's what a blockchain enables. A blockchain enables, or is, an immutable distributed ledger. Ledger means book. So a book of transactions, basically. And anyone can transact with anyone. And in this book of transactions, every transaction is recorded. And you can also say blockchain is kind of like, what's a block and a chain, blockchain? Well, the block you can consider as one page in this book, and the chain is all these pages together. That's kind of what a blockchain is. And it says distributed ledger, which means that every single one of these dots, or every single one of these participants, has access to the same book and can maintain the same book. So no one can lose the book. No one can say, oh no, it's wrong. It can't be wrong. Everyone has the same copy of the book. So that's what this allows. And immutable is the last word, and immutable just means it can't be changed. You can't falsify the book. So that's what it is. A book of transactions that everyone has and can't be changed, and is securely added to page by page, and each page has a bunch of transactions on it. That's what it enables. So this is made possible by a decentralized transaction clearing mechanism described in the original Bitcoin white paper. So the transaction clearing mechanism is what basically banks do. Banks kind of every day sit together every weekday, and they say this transaction is valid. And then they say deduct from here, add to here. And that's what they do every day, a few times a day. So what this paper describes, what the whole magic is of this Bitcoin white paper when it came out over, I think, 12, 13 years ago or more, maybe 14, is it describes this mechanism, how these transactions can be cleared without going through a centralized party. So this was the benefit. So how does this mechanism work? Now, I have a few slides that is, they're kind of a condensed version of how this whole thing functions. So stop me if you have any questions. But here's, in short, how this clearing mechanism works. So blockchain participants generate a public-private key pair. I hope this is okay. And what this enables, first of all, is the public key is their address on the blockchain. Kind of like if you want to communicate with a public key of anyone on the internet, that's what you use to encrypt messages. And the private key is only known to the private party. So everyone has a private key, and everyone shows their public key, basically. And there's two other things that are important here. There is a sign function and a verify function. A sign function means anyone can sign a message with their private key, and the verify function is anyone can take that message, look at the signature, and with the public key verify that this is in fact something that came from this authorized private key holder party. So these are two functions that are very, very, very important for this whole mechanism to work. And I feel that you're familiar enough with these two concepts that we can move on. So how the transaction process works is basically there exist miners. They're called miners, and what they do is actual transaction verification. And what they do is they listen to these messages of people saying, I want to send this amount of Bitcoin to this address, this amount of Bitcoin to this address, this amount of Bitcoin to this address. They make a list of these transactions, a page in the book, if you will, and then they decide, okay, I have enough transactions to fill out this page. Now I can verify that these transactions are real. And how does this verification work? So miners listen to the transactions that are emitted on the network, and they organize them into blocks or pages, and they proceed to verify them. Now this is the key point. How do you verify something in a distributed way? Well, the function that was described in this paper was that they have to satisfy a condition in a hashing algorithm in order to say it's verified. So the condition that was invented or was presented in this paper was, if we take a list of these transactions here, this is a page in the book, we have to guess a number called a proof of work. We guess this number such that the hash of all of this produces some form of number here that starts with a certain number of zeros. That's the condition. This is very, very difficult. And this is why it takes a long time to guess such number. But once such number is guessed, the amount of electricity required to guess such number and the number of attempts at guessing such number is the kind of proof that is required to say this actually works. So this mechanism produces, once it satisfies this condition, this hash of this whole thing, so everything here, is added to the next block at the beginning of the next block. Then new transactions are added, a new number is guessed, the conditions are met again, and then this is added to the next block, and so forth and so forth and so forth. So it's a book of connected pages that can't be changed. So that's basically what the clearing mechanism does. The proof of work number is guessed by miners in order to generate a hash. Why is it guessed? Because there's no better method. There's no more efficient way of finding the number than guessing the number. So that's why they do it. So the hash of the previous block is added at the top of the next block. Falsifying a block on the chain is very, very difficult because you would have to falsify the whole previous part of the chain or each subsequent block, which is very, very difficult. So this makes this mechanism very, very secure. That's basically how this whole thing functions. And the key here is you trust computational work instead of trusting a central authority. So instead of having to trust the bank saying this is the way this works, we trust the computers to guess the number, to say, okay, now everyone agrees this is the next page in the book, we move on to the next page. In this, we can never go backwards. That's the benefit of this. So what's the impact? The impact of this technology is kind of very, very interesting, very revolutionary to certain industries. And in fact, you'll find in the examples that I give is revolutionary to many industries. Many economic models will be changed in the next couple of years because they will rely on this type of technology. So Bitcoin is basically money in its truest form, but without the privacy. Now, you may have heard or read somewhere on the news that Bitcoin is too private or Bitcoin hides transactions. That's actually the opposite from the truth. There's no way to hide a transaction on the network. Each transaction is maintained from now until the end of time in this book of transactions. So it's full transparency, but the only thing that's hidden is the ID of each holder of each wallet or of each address. But if you find this out in some way, you have the whole history of transactions, which is the opposite of cash. In cash, there's no history of who transacted with who, but with this, there is. So this is a problem because the other problem is that anyone can see how much money is in each wallet's account or in each wallet. So this is something that you may not want. Why would you want someone to know exactly how much money you have? You make yourself a target, basically. So this can be a problem, but in its current form, this is how it functions. Now, I mentioned also here that Bitcoin is money in its truest form. Why do I say it's money in its truest form? Well, money has three characteristics. Do you guys know what they are? What's the function of money? Money has three functions. The first function is a medium of exchange. So the first function is you transact with the money. Second function is a store of value. That means you expect your money to be worth the same today as it is tomorrow. Is this true of money that we use right now? Not really, because there exists a central authority that can change the quantity of money in existence, therefore changing the price of money. So that's not usually true in today's money that we use. And the third function is it's a unit of account. A unit of account means we can measure a certain good or a service in this currency. So these are the functions of money. What we use as money today usually satisfies two out of these three. So it satisfies medium of exchange, dollars, euros, rupees, whatever. It's a medium of exchange and it's a unit of account. But over time, it cannot be considered a reliable store of value in any country, basically. So that's the problem with currency today. How does Bitcoin or other cryptocurrencies solve this problem? Not all of them solve this problem, but Bitcoin in particular tries to solve this problem because it can be used as a medium of exchange, it can be used as a unit of account, but it also has problems with the store of value component because short term, it can be very, very volatile in terms of price. Over the long term, it's usually not so volatile. It actually goes up instead of down if you consider a long enough window of its existence. So that's why Bitcoin can be considered money. So it exists in a finite quantity and is fully self-custodial, which means you can't print more of it. There's a finite amount of how many Bitcoins can exist, and you can hold it yourself. You don't have to rely on a bank or a third-person trusted entity to hold your Bitcoin for you. That's the benefit of it. It's also a downfall. It's also a benefit and not so much of a benefit because it requires responsibility on your end. And once a transaction is enacted or transacted, it cannot be taken back. So that's one thing that needs to be addressed, but cannot be addressed with this technology. It's just something to think about, basically. So that's it can't be confiscated, and its transfer between parties can't be blocked also. So because there doesn't exist a central authority, no one can say this can't happen or you can't transact with this person. We can't enact sanctions against someone in the network, which is beneficial because today's political climate is kind of difficult in that regard. Between countries, I mean, not between entities within countries. So what else? A decentralized transaction clearing mechanism has never been possible before Bitcoin. That's kind of the benefit of it. And it can be considered blockchain to finance what the printing press was to education 500 years ago, especially in Europe. That's kind of the revolution of it, because it has a similar impact. It will disrupt, or it has already disrupted industries to the point that governments don't know what to do with it. They tried to regulate or enact certain legislation. Some countries ban it outright. Some countries actually piggyback on this technology and will issue their own central bank digital currency that has some of these characteristics, but not all. So it will be a topic, and already is a topic of discussion going forward. So we are experiencing the fastest, as in we means the world, are experiencing the fastest adoption of technology, blockchain, in the history of the world, faster than the internet in the 90s. So there are more new users using blockchain every day than there were new users in the internet 30 years ago and more. So it's encouraging because people do consider this something worthwhile. So that's currently the state of things. There are, however, people that don't agree with this. So this is just one example that I found last week in the news. I'm not sure if you're familiar with this person. This is Yanis Varoufakis. This is a former Greek minister of finance that was central to the Greek episode a few years ago when Greece was facing expulsion from the EU and bankruptcy and all these things. He was one of the key figures in Greece trying to negotiate a settlement with the EU. And he actually criticized Bitcoin specifically, and he said that Bitcoin cannot be money in a capitalist system because he argues that its attribute of being finite in existence, so 21 million can never be more than 21 million. He thinks this is a bad thing. He thinks in a capitalist system we need a flexible money supply. And his example that he gives, he says during COVID, governments were able to print money out of thin air. This is his words. Distribute it to people, and otherwise it would have been much worse for people if they were locked in their own homes, couldn't earn a living, and then they would have starved basically. So the government kind of helped them by printing money. This is what he said. I argue that without this printing ability, governments wouldn't have been able to lock people in their homes at all. So I'm not sure how this is related to capitalism or not in how he describes it, but I think the monetary system is one thing, and the economy and how it functions and private ownership is something completely different. But some people try to link these things somehow. So what is this used for? What are the commercial applications of cryptocurrency? So there's a few. Many separate blockchains do exist. Some rely on Bitcoin core technology, some rely on some other technologies, but some of them are built around a specific purpose. And one of the main purposes, apart from just the transactional nature of Bitcoin, is a smart contract. And a smart contract is just a contract. So instead of sending just a number from account to account, you can send information. You can send a series of clauses between parties that have to be respected. And this is something new as well, relatively new, a little bit newer than Bitcoin. So you don't have to send only numbers. You can include clauses. You can include a whole series of transactional steps that need to be required to execute. So for example, I'm not sure if you're familiar with Kickstarter. This is this is a popular website in the West. It's a centralized application where people try to gather funds online. So they have an idea. So this is the project. They have an idea for a project. They need money. So they go to this website and they describe this project to their users. And then if you're interested in supporting the project, you can give money to the project directly. And it works it works this way. If you're interested in the project, you give money to the project. And if the project collects as much money as they say they need within a specific period of time, then they get the money, basically. But if they don't generate enough interest to get the money that they require, then the money is sent back to the users, and that's it. So this is a perfect example of something a smart contract can do. You can program this. You can say, okay, send money to this address. If this address picks up enough money in a certain period of time, then this money gets transferred here. On this date, if it doesn't, then we send it back, and that's it. So it's a decentralized application of something that currently happens in a centralized way. So this is Kickstarter. And this is something that can and will be built without a central authority, which is the website Kickstarter in this instance. So what else is possible? Decentralized finance. This is something that was popular last year, I'd say, was a pretty popular year for this type of technology. This is something called Uniswap. And it's a large decentralized coin marketplace, which means if you want to come and trade these coins between each other, then up until this point, you'd have to go to another centralized authority, an exchange, send some coins there, trust that they will do what they say they will do, and then transfer your transacted coins to another address after you finish the transaction. What Uniswap does is it does the same thing, only without a centralized party. So it's a decentralized exchange where, and I won't get into the protocol here of how it works, but you have one market for each pair of coins you want to transact with. You send your coins to this contract. You get the thing you're trying to buy right away. So it's just a way of transacting that doesn't involve any centralized parties. And transaction fees are paid in these tokens that they issue, and I'll get into that a little bit later as well. There's another application that's interesting, is connecting the crypto blockchain world to the real world. So this application is something that's called Chainlink, and this is one of many that do this type of thing. And what this does is a token that gathers real-world decentralized data that can be relied upon as input to smart contracts. So what this means, for example, I have a picture here. Let's say you're a farmer and you grow this crop and you want insurance on this crop. You're saying, okay, if it's really, really hot this year, really, really hot, and my crop fails, I still want money from an insurance company so I can live, basically, for next year. So you would have to trust a centralized insurance company for this to take place, right, in order to get paid if you have insurance of this form. So what this type of thing, what this technology enables is something like this. Let's say you're the farmer here and you want a decentralized insurance mechanism. You want to go to a pool of people that will offer you insurance, but the contract is defined as follows. The contract says, if the temperature goes above a certain level at any time, any day of the year, you get a big payout. If not, you spend a little bit of money each month supplying the premium to the insurance company or to these users here. So the only trick in this mechanism is, how do you know, how does the smart contract know when the temperature goes above a certain point? And the only way it knows is if it has a mechanism of interacting with the real world and kind of measuring the temperature every day and saying, oh, today it's too hot. Activate the clause in the contract saying, pay these people this amount of money. So this is another mechanism of what's possible of connecting the actual smart contracts, actual digital contracts to the world, to the real world. There's another application called stablecoins. And these are also cryptocurrencies whose value is pegged or fixed to that of another currency, one-to-one. So for example, Tether is the most popular one currently. It fixes $1 to one Tether, and you can transact in Tethers online and not go to a bank. That's one thing. It can be sent pretty cheaply across multiple blockchains, and holders can gain a yield from holding Tether via lending if you trust the platform that you're dealing with. And it can be redeemed for US dollars via an exchange or the Tether company itself. So stable coins exist for multiple other currencies. For euros or pounds, but for dollars they're the most popular because currently the dollar is the reserve currency. Another interesting thing you can do is you can tokenize a person or an entity. So we discussed this a little bit yesterday as well with some people, and what's happening or what will happen in the near future, year or two from now, is you can issue shares of yourself. So if you're, let's say, a musician, or let's say a sports star, or an athlete of some sort, or you produce something of value to someone, you can say, okay, I need capital right away, I need money right away, but I'm willing to offer my future earnings to the pool of people that will support me right now. So I can say, okay, 5,000 shares of me, if you buy these shares for the next 5 years, I guarantee that I'll share this income with you via the blockchain as well. So this is a way of kind of monetizing yourself, and or at least generating capital right away for funding yourself for these endeavors. So tokenizing is converting any real entity into a divisible digital property, and NBA players have tried to do it, like this guy. He wasn't successful, the league didn't allow this, but it was an idea. So we'll see, we're monitoring this going forward. He wanted to sell his contract to investors to get the money up front, basically, and then have his guaranteed contract pay out monthly salaries to the holders. So in real estate, you can also do this because I don't know how it works here, but there have been problems across the world of trusting the government's central bookkeeping of who owns what land, for example. So this is another application of guaranteeing that your land is owned on the blockchain and no one can change that. So that's another application. It's been tried in the US and France since 2018. This has been possible and legal as well. And another application is with high-end brands like Louis Vuitton, Gucci, Prada, and so forth. They, I don't know if they started, but they were planning on, there's a link here, they were planning on adding QR codes to their merchandise, and then you can scan the QR code and say if the bag or the item is on the blockchain that they guarantee was an actual real item that they produced, so you don't have to deal with counterfeit items, counterfeit goods. And that's how they marked it. And this also works in food production. You can kind of like verify each step of the food cycle, of the food production cycle, and kind of see where the problems are in case there is a problem, because every single step can be put on a chain and saying, okay, where's the problem here? The other interesting thing, and this is the last one I think in business terms, is putting a value on an intangible asset. So goodwill is something that companies kind of keep track of. They're saying we're a very big brand, and the goodwill towards our brand is worth something, which is true, but it's hard to measure. So these tokens allow people to kind of put a very real value in good things like goodwill. And how they do this is they can issue a coin, they can issue a token for a company. Let's say you're, and this has been already happening already, let's say you're a sports team, you're, I don't know, Real Madrid, and you want to issue a token to your fans. And your fans kind of can buy this token and kind of trade it. And if your team performs well, the price of the token increases. If it doesn't, the price decreases. And you could also ask your fans, the holders of this token, things related to management. What would you like to see in the future? And then you can kind of get direct feedback from people who actually have a stake in the business. And this is another company, Chili's is another company that issues these tokens. So fans can trade the tokens, and right now they have teams like Paris Saint-Germain, Manchester City, Barcelona, and so forth that actually issue these coins and kind of play with them, issue them to their fans and see what can happen. So this is kind of the same thing as I mentioned with music. This is with sports teams, that they can actually put a number on how valuable is it to hold this token. That doesn't really mean they own the company, but it means they interact with certain aspects of the company. So that's a way to measure goodwill, basically. So research problems, a couple examples of what's possible in the world of research related to blockchain. This might be the most interesting for you. So one thing is privacy. The typical blockchain is an open ledger where you can see all transactions and you can see all balances. So this is the Bitcoin standard. There are other blockchains that are completely private as well, where you can't see any transaction, you can't see any statement, but you can verify the transaction happened. So this is one thing where maybe we want something that's a mix of both.
And one thing that's relevant in India, for example, Personal Data Protection Bill 2019, I found. And this does not allow for the right to be forgotten. By this, I mean blockchain. So if you're on the blockchain, there's no way to delete it. So it's in conflict with this law saying you have the right to be forgotten online. Yes, but no at the same time, because we can't change the blockchain. So this is incompatible. So transactions between parties should be private, that's the other problem. But currently they're not, in Bitcoin at least. So in 2017, Supreme Court of India pronounced a landmark judgment declaring the right to privacy as a fundamental right under the framework of the right to life, Article 21 of the Constitution. So how does this mesh with the law? So it's another aspect of something that needs to be kind of investigated. So privacy in blockchains. Blockchains such as Monero, Dash, and Zcash include zero-knowledge proofs, which I hope some of you are aware of, and transactions are private, but the owner of the wallet can issue keys for auditing purposes. This is the other end, the other aspect, the other end of the spectrum. How can we execute a cross-chain transaction between public and private blockchains? So if one is public, one is private. How can we guarantee a decentralized a mechanism of changing coins from a private to a public blockchain, for example, without a central authority in a decentralized fashion? These are open questions. These are just things that people are thinking about right now and need a solution. So if you're interested in this field, then it's possible to kind of discover this or look into this. Scalability is another issue. I mentioned that a blockchain has pages, basically, and it's pages in a book. So one of the issues is how big are these pages and how quickly can we turn these pages? So this is the idea. Security, decentralization, scalability in a blockchain networks are hard to achieve at the same time. So maximum 2 out of 3 can be achieved. Either security, either decentralization, or either scalability, 2 out of 3. It's very difficult to do all 3 at the same time, which is another topic of research discussion. So Bitcoin can scale to a large number of wallets, but not to a large throughput of transactions. It's usually, I think, in the low single or double digits of transactions per second. So I don't know, like 10, 15 transactions per second. I'm not sure what the exact number is. It's because it's a fixed block size, a fixed page size, and the average confirmation time is about 10 minutes. So the Bitcoin Lightning Network is something that's new. It's another network on top of Bitcoin that attempts to solve this problem, but it's not an easy fix, I would say. There are some steps involved in making sure that these transactions happen over this network. I don't have time to go into this right now, but you can look this up. Scalability, the other thing is execution, storage, and consensus are limiting factors to scalability. So these are the steps. How fast can it execute? How much storage is required? And how many actors are required to make sure that this is the next page in the book? This is the consensus part. So the blockchain can require a large amount of storage space, which limits the number of transactions miners can use. And the other limiting factor is computational power. It may be too big, and this may be a problem as well. And if you try to reduce it, then you reduce decentralization, and then you run into other problems. So it's a trade-off. It's a trade-off between all 3. Blockchain analysis is another area of interest. This is actually scanning the entire network and kind of analyzing what's happening between actors. So imagine you had a way of knowing who transacted with who, even with cash. You can analyze the inner workings of the economy. It's a very nice data set to have, but it's impossible to have right now because of cash. So if all transactions were fully transparent, you could actually analyze how monetary policy impacts the economy, how each individual spends money, and then kind of learn based on their spending patterns how to implement certain monetary tricks to optimize the economy. That's kind of the idea. So given the transactions are fully transparent, what can be learned from observing how each one transacts? So there are companies that do this. There are companies that kind of base their business model on analyzing the open ledger and kind of seeing transactional patterns and trying to predict prices, trying to predict behavior, trying to predict many other things. So this is analysis of the blockchain itself. This is another research topic. This is called tokenomics or token economics, and it quantifiably demonstrates micro and macroeconomics on real data, on real transactional data. It enables people to cluster groups of users or individual users into groups based on their behavior, on their income, and on their wealth and other factors. So this is like analysis, basically big data analysis of transactions. And it also may be possible to predict the future behavior of market participants based on blockchain data. What this means is, if you can learn how someone spends money, you can predict what they're going to buy next, basically. So that could be interesting. And one of the last things is Web3 business. Web3 is basically what we're talking about right now. So in trying to introduce a monetary system on the internet directly, that's what Web3 is. Web2 is known as the platform application economy. That's what we have on our phones right now. Web3 is known as the token economy, which means these applications, once they accrue a certain number of users, they kind of want to introduce their own tokens. And this is what happens with Facebook, with Telegram, with other applications. They want to introduce their own money, because why not? If countries can do it, why can't companies do it? That's their logic. So they've tried. Facebook, Telegram, they wanted to monetize their user base by issuing a currency in their app. And so far, not so good, but we'll see. Hope maybe some of them will be successful. And also, when they try to do this, how can they do this while remaining compliant with local laws? So that's another thing that's worth taking into account. So are there any local laws that govern this? This is another issue, because governments are a little bit behind in regulating things that are so new. So even if they're able to do it, what are the implications? And one of the last things is a metaverse. This is another application of blockchain, which is what Facebook is trying to do. So Facebook, the creation of all-purpose 3D virtual worlds, right? That's what they want. And they want this for trade, education, employment, networking, and everything else. And all of these worlds will require their own currency. So that's their kind of way around, I think, certain legislation that enables them to issue their own currency. So that's what another issue is. And within these metaverses, there are things to study. There's things to research, such as governance models, digital ownership in the blockchain, in the metaverse itself, the currency that can be used in the metaverse, how can it transact in the real world as well. So these are things that can be studied. A couple other things: fraud detection and financial crime prevention. So successful criminal activities such as theft cannot be rolled back on the blockchain. So how can we address this? How can we account for someone stealing, someone forcing you to send them your money? How can we roll this back? Currently, it's impossible. So how can crime be punished if it's impossible? How can funds be returned? So these are open questions as well that someone should study and see if we can find an answer to this. And can enforcement be carried out in a decentralized way? Which means, do we have to rely on a certain central authority such as police, or can we decentralize policing also? Is it possible? And the conclusion is, blockchain brings transparency to the world, and transparency is the foundation for trust. And without trust, societies crumble. So basically, blockchain is a positive force in the world, and a pivotal economic technology. And like all technology, it can be good, used for good or something else. So I mention this specifically because governments want to take something like this in each country. You can go on the website of each central bank of each country, and they're all working on similar projects. They want to make their own digital currency that's going to compete with Bitcoin, but it won't have the same characteristics. So it won't be limited in quantity, it won't be completely private, it won't be decentralized. It'll be the opposite, but they will claim that it's, going to be the best thing ever, but it comes with problems. So you can study that. You can see where that leads you as well. And if you have any questions, you can ask me now, or you can send me an email here as well. Go ahead.
So on 13th slide, you have shown Kickstarter example.
Kickstarter, yes.
So one way you have explained people around can help in some kind of fund.
Yeah.
And founders will get that fund.
Yes.
If that optimum won't be achieved, then they will return.
Yes.
But what they will get if that optimum amount has been received by the founder, how they will pay these audience back, or is that something?
Oh, you're asking what's the motivation?
Yes.
The motivation is, if you finance this project, the project claims to give you bonuses based on if they get funding or not. So if you give them a little bit of money, you get a token thank you note. If you give them more and more money, you get a sample of their product they're trying to produce. So for example, there was a company making wooden puzzles, and they wanted money to produce these wooden puzzles. And if you give them enough money, they would send you a wooden puzzle at the end. So you basically have a right to purchase one of their wooden puzzles at a discount. That was the motivation. So each project motivates people to give them money and then gives them something in return.
Okay. One more question. So on data privacy,
Yes.
you said India's law is that. So right now, what is the situation? So because of law, do we have currently any blockchain
I think
products or
owning and transacting in Bitcoin is currently legal in India. I think it was illegal previously, but I think it's legal now. But I think I think it is. You can check. You can check. It was illegal, but now there are companies that actually do it, and it is legal. It's just highly taxed, I think, in India. You can, I mean, maybe something's changed in the meantime, but you can check that out.
No, basically now India is producing its own currency. Okay, that is in the pilot studies is
Yes.
going on. Okay, so that is a separate concept. Things that I will not discuss here from India. So I want one question here. How you can think about the future of cryptocurrency?
I don't know.
Because
no one knows.
I also invest some money in Binance and Azidex, all these things. So it is completely volatile in nature that we can know that. Okay, like Bitcoin price or Ethereum, Ether, whatever you can say. So whenever we have to think about the public blockchain to go for the implementation of any applications, so obviously the money involvement will be there, and that will be fluctuating. Okay, so how that is nowhere we can find out where the real applications of the blockchain till now.
Oh, there are definitely real applications to the blockchain. Money is just one application. So there are companies that actually make money from this technology. And if you're asking what's the future like in terms of will it collapse or will it continue to grow, there's one statistic that I know that if you take any 5-year window of the price of Bitcoin and you buy on day one and wait 5 years, you will never lose money.
That's
So
whatever
that's-
you are saying, that's true.
That's one, but it doesn't have to hold in the future. Who knows? But no one can tell you that. All you can measure is basically the number of users. If the number of users keeps increasing, then the technology is relevant. And any application is relevant that uses that technology in the number of users in that blockchain. That's the measure that you can use.
So can we think all applications we can implement blockchain?
Probably not.
Probably not.
Probably not, but I think many you can. I think you can implement stock market and financial transactions. You can implement video games using or metaverse using this.
Yes,
Yeah, you can anything where transactions take place. The transactions can happen in a distributed way, so that's for sure. But where can we take this? I don't know. But I think many things will converge to a blockchain because it is a transparent solution for all.
Most important question is how you can storage the data whenever you have to create a Genesis block. So after Genesis block created, then many other blocks are created in the transactions. But storing is the major issue nowadays. How to do all these things?
I think storage is an issue in terms of user interface, because users are afraid to store this because they might make a mistake. So I think that's true. I think one of the things that needs to be worked on is how to make this more user friendly for everyone and build trust in this mechanism. Because a lot of people, even if they understand what's going on in theory, they're kind of afraid to touch this because they might make a mistake. So this is definitely something that needs to be really looked at to make giant increases to build trust, I think, for sure.
Okay, thank you, sir.
No problem. Yes.
So by 2140, like 21 million bitcoins will be mined, and there the process is going to be stopped.
No.
No.
It won't stop. It's just that the issuance of new Bitcoin will stop. But transactions will still take place because if you want to issue a transaction, you reward the miners saying, okay, if you process my transaction, here's my fee that I will pay you. So it will still take place, it's just the miners will earn income based on just one method instead of two. Currently, they get two methods. There's a transaction fee that you issue to the miners, and there's the network reward that's issued. Once all the network reward is gone, only the transaction fee remains.
Is there any scope that after 21 million bitcoins have been mined, so they may be increased or like
No.
Okay.
This is fixed. Unless the network together decides that it needs to be increased, which is unlikely because you need half the network to agree to this, but it won't, then it can't be changed.
Okay, one more question, sir. So in the process of mining, okay, if the miners are going to solve a puzzle to do that process, if none of the miners are going to solve the process, then what can be the next thing? For any transaction to happen?
You mean the miners decide they won't do any more work?
No. If there is a puzzle to be solved to get to process the Bitcoin,
Yes.
if none of the miners are going to solve that puzzle, no one is going to solve the puzzle. What could be the next?
There's no others. There will be miners to solve the puzzle because there's a financial incentive to solve the puzzle. It's like you get paid to do work.
So there won't be any.
Someone will get paid to do the work. It's just a question of price.
Okay.
As well, right? If you reward the miners a little bit, then they're less motivated to do the work. If you reward the miners a lot, they're very motivated. And if you look at miner, it's measured in difficulty. So how difficult is the problem? And the more miners there are, the more difficult the problem is because they want to keep the time constant.
Hello, am I audible?
Between pages or between blocks. So I think even with everything that's going on, I think the difficulty is increasing over time. And now we're also at all-time high of difficulty. So that kind of tells you that miners are motivated to do their work.
Okay, sir. Thank you.
No problem.
Thank you, Professor Milos, for giving detailed insights on